So this is a model of eye which is provided by BioCloud 3D. So as you can see, uh, the pathway of aqueous humor, it is produced here and going over there. So just to give you overview of the structure, this is the lens, this is the zonular fibers, this is the ciliary body, here is the iris, and here is the trabecular meshwork. This is the cornea, and here is the sclera. So, as you can see, the aqueous humor is produced from the ciliary uh, bodies, then going anteriorly from the iris towards the trabecular meshwork. I hope you can see the trabecular meshwork. I'll just zoom in a little bit. Yeah, so the trabecular meshwork is very uh, clearly visible now. So, after entering into the trabecular meshwork, the aqueous now moves into canal of Schlemm, which you can see here. So, this is the canal of Schlemm here. Yes, right here. This one. So, through canal of Schlemm, the aqueous then moves into the uh, veins. So this is the major pathway of aqueous outflow. There's another pathway, the uveoscleral pathway. As the aqueous is moving here, there is no epithelial barrier, due to which the aqueous is directly able to enter the loose connective tissue of the ciliary muscles right here, uh, directly here. So that is another pathway, which is not the major pathway, but it surely contributes to that. And if you look closely, let me just zoom in a little. If you look closely, the trabecular meshwork, it uh, think of it around the whole globe of the eye. It forms a circular structure like this. This is known as line of Schwalbe. This structure is important when you are looking at the angle, the iridocorneal angle through gonioscope. And this right here, the canal of Schlemm, is just above the scleral spur. Uh, so if you see this projection of sclera right here, this is known as scleral spur. This is also useful to identify the canal of Schlemm when gonioscope is done. Now, just I'll just summarize mechanisms of glaucoma. Consider as so there are basically two types of glaucoma. One is open angle, one is closed angle. So this is the angle, the irido, the iris, the cornea, corneal angle, and the angle we have the most important thing, the trabecular meshwork through which aqueous passes, and the uveo outflow is also just close to the meshwork, just around here. The humor passes just here for the UV scleral pathway. So if the angle closes somehow, and the pathway of aqueous humor outflow is blocked, which can cause accumulation of the aqueous humor and can cause glaucoma. Similarly, there is another type of glaucoma, open angle glaucoma, where angle is open but still glaucoma occurs. So there are also multiple mechanisms for that. Now, one of the very important thing is inflammation. Con- so there is one thing known as Seneca, which is basically the uh, adhesion. So adhesion can occur either between the iris and the lens or iris and the cornea. If adhesion occurs between the iris and the lens, this can cause this is known as posterior Seneca or posterior adhesion. So what happens is the aqueous comes here, but due to the adhesion of the iris in the lens, it is not able to pass anteriorly, which causes the accumulation of all the aqueous humor here, and the iris is now pushed forward due to the accumulation of aqueous humor here, which then also closes the trabecular meshwork and uvascular pathway. So this is a mechanism of one of the mechanisms of glaucoma which occurs due to inflammation. Senescae mostly occurs due to inflammation. For example, uveitis. So here's the uveal tract. If inflammation occurs, senescae can form. Similarly, there is anterior senescae, which can occur when the iris touches the cornea and get adhered here. This also blocks the pathway of the aqueous humor outflow. So there are many multiple strategies to control uh, glaucoma. Uh, one is very simple. We can just somehow increase the area of the trabecular meshwork. How can we do this? This we can do. Just consider, like, if we try to pull this iris forward here, like here, the area will increase. So this is exactly the mechanism of miotic pilocarpine, which increases trabecular outflow. And another mechanism is by decreasing the production of aqueous humor, which is done by beta blockers. Their main mechanism of action, such as timolol. So the beta blockers decrease aqueous production by decreasing the intracellular CMP concentration. There are also alpha 2 agonists, uh, which also decrease aqueous humor production, but they do so by contracting the ciliary muscle in the body, due to which the production of aqueous decreases. So beta antagonist and alpha 2 agonist are two more drugs. Then we have some other drugs as well. There are prostaglandins which secretes matrix metalloproteinase and just open up more spaces around here. There are another new class of drugs, Rho kinase inhibitors, uh, which mainly act through trabecular meshwork by increasing the outflow. So here's another overview.